So we're going to show you the geostatistical wizard and an introduction to how you do some analysis with it to interpolate. But this is the barest of introductions. This is quite a complex tool, and we almost don't want to show it to you because there's a lot of background to apply this tool properly. You really need an additional course. But for the folks that want to do more advanced things, this is sort of an entree or maybe a teaser into what you can do. So here we have the geostatistical wizard, which we find in the analysis tool. So you have various tabs here. And if I go to the analysis tools and click on the geostatistical wizard, I have this whole menu of different kinds of tools I can apply. So kernel interpolation or local polynomial or inverse distance weighting. We'll start with the easiest one here, this inverse distance, I should say the simplest. We have a source data set and then a data field that we want to interpret. And typically we have a set of parameters that we see through various windows as we step through. You can do weighted inverse distance. We're not going to go through that. It's described a little bit in the text. So if I go to the next screen, it notes that some of these samples are overlapping. Actually, there's only one pair and they're very close together in lat long, and it puts them in the same place in the rounding. But we're going to go ahead and use the mean for these two. I know that's appropriate for this data set. And so you go to next, and again, you have a set of parameters in this next field, so you can change the power. You should know what this means from the reading. Higher powers means you get a closer influence for the nearest point. And you can see that if I go to, let's say, a power of 4 instead of a power of 1, and it automatically does the fit and gives you this preview to show the impact. Now, you're not going to use this more than just a quick visual check, so we'll stay here at a power of 1 rather than these really high powers. Now, you can change the number of neighbors here. So if I have a large number of neighbors, that means the influence from something further away counts. Otherwise, if I have a small number of neighbors like 5, again, and it'll automatically set the minimum number down, you get a closer influence or closer importance, so that you don't look as far afield to affect the analysis. And each of these parameters will affect then the shape, and so you have to pick or know what's an optimum or at least a robust set. You get that through experience and then through some diagnostics that you can see in this next screen. This next screen is perhaps the most useful. It gives a cross-validation. So for each of the points that you have, it pulls it out, does the fit, and then sees what the error is, puts that point back in, grabs the next point, fits with that point excluded, and then sees what the error is that point is. And so it looks at, as about as independent as you can get, an estimate of how good the fit is, and it can calculate a mean error and a root mean square error. So this figure of merit in a cross-validation is a reasonable first cut. So this is the one-to-one line, the line of perfect prediction, or you can look at the error here, see how the error changes across space. So we have a range of errors that occur here. So the values, 0.6, some of them are negative in the location here. So this means our predicted ozone can be off by as much as these values here. And so they'll give you a distribution of the error too, what sort of the average error is, to see if there's long tails. So once I go back and get a set of parameters I'm happy with, and I verify that with the error plot, I finish, and it then gives me diagnostics and fits the model that you have chosen and gives you an output then surface. And so I have this inverse distance weighted surface here, and I can then color this as I did the others. So if I look at the symbology for the input distance weighted, I can go then to the same 3 classes with the same 3 thresholds that I picked before. Right, so I can set this value here at 54 and this value at 70 and get a surface then that shows where there's high ozone, intermediate ozone, and then ozone levels I don't have to worry about. So we ask you to do that for the various options in this geostatistical wizard. We ask you the inverse distance, the kernel interpolation, and this kriging, co-kriging. And in each case, we want you to use these same source data and input data field and look at the various options we suggest to you to create surfaces, which then you'll then put in a grouped map.